This recording is protected by copyright. No part may be reproduced without the prior permission of the University of South Australia.
Before I go through today's topic, I thought you might be interested to know that I've put the assignment specs up on the course website, so I'll just quickly go through those for you. So let's start first. I've put up, as with the other assignment, a group Q&A forum. This Q&A forum is basically open to everybody, so everyone can see what's on there. So if you've got any questions in relation to the assignment, please don't email me directly. Email the Q&A forum, and that way everyone can benefit from the response that I provide. Unless it's obviously a personal question, you can email me, but if it's assignment related and generic to the course for this assignment, please use the Q&A forum. Over the break I did post up the groups that you are in for systems analysis. It is really critical that you do ensure that your name is in the correct group, because I've set these up also on the system, so when you submit your assignments, the submission will be the same across all members of the group, and the feedback and the mark will be the same across all members of the group, unless some changes are made. So it's really important that you make sure that you are in the same, or that you are in the correct group as indicated in this particular document. So I've put up the specs, a rubric and a template. So let's have a look at the specs first of all. So the assignment is due 11 p.m. Sunday 29th of May. It's worth 25%. Now it says 2,000 words, but it's kind of a little bit irrelevant in this assignment because you do have to do quite a number of diagrams. So although it says 2,000 words, it's a total of 2,000 words plus a whole bunch of diagrams.
Is that 2,000 words per person?
No. Okay. So it's 2,000 words in terms of the words that need to go in the assignment, but there are quite a number of diagrams you have to do. So it's 2,000 plus all the diagrams for the whole group. So it's got to be in the groups that have been approved by your tutor, and as per that list that's on the website, we will return submissions within 2 to 3 weeks. Having said that, your first assignment, within the next week, you'll get your feedback, if not sooner. I say week, just being pessimistic, but you should get them relatively soon. So feedback on this one will be provided on the rubric, again, which is on the website. Please read the assessment summary. Again, no late submissions, otherwise you get 0. No resubmissions after the fact that you've submitted, otherwise it's counted as a late submission and you get 0. Okay, so I've had instances where students submit it and they think they've done something wrong, or they've got a high Turnitin report and then they resubmit after it's due, and then it shows it. So you can resubmit before the due date as many times as you want, but if you resubmit after the due date, it shows it's late and then you'll get 0 because basically you can have the advantage of changing it after it's due and then resubmitting it. Okay, so bear in mind also, if you resubmit, make sure you don't change the file name, otherwise you'll get a 100% match on your Turnitin similarity report. So specs, basically think about your role as a systems analyst. I'll be getting you to basically do a whole bunch of activities in relation to what we've been doing throughout the course, and you'll be coming up with a pretty good specifications document for a particular system. So we need to look at and document system requirements. You need to look at use cases, do some domain modelling as well as use case modelling. So as I've said here, the word limit applies to the text sections of the assignment. The diagrams are in addition to the word limit. Please create the assignment using the template I have provided on the course website, and I will show you that in a moment. Each member is also required to fill out the declaration of contribution form, which again is in the template, and I'll talk about that in a minute. These are the things that I'm looking for when marking your work as per the rubric. So here are the instructions. You must submit online, via Learn Online. Only submit one assignment per group. Okay, so pick someone, dedicate someone who's going to be the submitter of the assignment, because if more than one of you submit different versions of the assignment, then the latest person that submits will overwrite the submission of all the others for your same group. Okay, so only one submission per assignment, please. Include as part of your submission one PDF document. Okay, you're creating a whole lot of diagrams, and using Word and lots of other tools tends to muck about diagrams when we print them out or when we look at them on our screens, which is why I've asked for you to convert them to a PDF document. So then we go to print or mark your assignment. What you see is what we see. Okay, makes sense? So PDF submission. Individual submissions will not be considered or marked.
Can you convert a Word document to a PDF?
Yes, you can. Yes. Do it all the time. And again, don't bother copying. Don't make me waste my time checking high Turnitin similarity reports, because I don't really want to, and you shouldn't be doing it anyway. That's basically what that stuff says. Don't copy, otherwise we'll have to take further action. So I've given you a scenario here, which I'm not going to read. But this is what you have to consider in terms of responding to the questions which are on the following page. So next page for questions. So very similar questions to what we have been doing throughout the tutorials this study period. Looking at system requirements first, who are the stakeholders, looking at functional requirements, primary functional and non-functional, looking at actors, looking at use cases and use case descriptions, drawing a use case diagram, domain modelling, which we've been looking at this week and in the previous lecture. So you need to do a domain model class diagram, a state machine diagram, which we'll be looking at today, and then following on with use case modelling, which we'll be doing in the up and coming weeks. You need to write a developed use case description for the use case book car service. So it's for a vehicle mechanic service organisation, and I've specified which use case I want you to create, as well as the activity diagram for this use case, as well as the system sequence diagram for this use case. Okay, so I've given you the specifics of which use case I want you to work towards. Please justify and document any decisions and assumptions made. Okay, there's no 100% right answer. There's no one correct answer. So if you're going to make assumptions on what you're presenting to me or your tutor or whatever in this piece of work, please state any assumptions that you have made, if you find it's necessary. Yes, Karen?
So do you divide those 4 questions between each group member?
You can choose to divide the work however you wish. So you can all do bits and pieces. I'll talk about a strategy about that in a minute, but yeah. So you've got to use the template that I've provided in the course website. Diagrams must conform to the UML notation, so forget about using Microsoft Word right away if that's what you're thinking to create your diagrams. You must use the diagramming conventions that we've spoken about throughout this course.
Does that mean we can't draw it?
Yes, it does.
Oh, it says there, or hand draw.
Oh, you can hand draw in this one. In this assignment you can. Okay? The other one I wanted you to get some practice in. This one, because there are quite a few, you can submit hand drawn if you so wish. But it must be legible. So take a photo of it, upload it, whatever you want to do. Okay? I've got the thumbs up this time. So the first one I wanted you to practice. This one, I'm sure, I mean, look, the majority of you probably will use a tool if you found something that you're comfortable with. But if you feel the need to hand draw it and you feel more comfortable and confident with doing so, and it is going to be legible for the marker, then I will accept it for this particular piece of work. So, again, for that Turnitin similarity thing, I've got here, do not include the scenario or the question text in your assignment. I should have actually said that for the first assignment as well, which I forgot because some of you did include the question text and you did have high similarity reports and I did have to go in and check them, so that was probably something I should have considered then as well, but no need to include the scenario or question text. Again, if you've got any questions in relation to the scenario or assignment, please post them on the Q&A forum. Now, let's go back. So that's the specs. This is the rubric. Similar style to the first assignment that I put on the website, but basically I'm showing you here the assignment is worth, it's out of 100. There's quite a few criteria that we're looking at, and those criteria basically match the questions that I've given you. Okay, so system requirements, part A, B, C and D, and I've given you some guidelines here as to what we are looking for and what we are expecting in terms of your responses to those parts of each question. Okay, so yeah, I think it's pretty self-explanatory. The rubric and the group template, the last thing. Not like that. There we go. Probably just to that gentleman there, right there. Okay, so declaration, yeah, obviously you need, just read that, it's a template I've created, delete the text before submitting. So the declaration of contribution, I would like you to put your team number, your group numbers on there. You've all been allocated group numbers. Incorporate your name, say what you contributed, how many words you contributed, and what sections you contributed toward this assignment. The objective of this is to ensure that everyone contributes equally and fairly. Okay? And if the instance occurs where someone doesn't, then I expect it to be represented in this declaration of contribution. If that's the case and someone does do half the work, they'll get half the marks. If someone does no work and it's represented here, they'll get no marks. Okay, so if you want to fudge the document and say that you've all contributed equally and fairly, that's up to you, but I don't encourage it. If you think you're going to do no work and get your other group members to do all the work, it's highly unlikely that they're going to be willing to put your name on here and say what sections you've done. So it's really to produce fairness and to ensure that everyone does contribute fairly and equally, and that I can see that. And it's at my discretion as to how and if I need to adjust marks as necessary. Okay? So for all intensive purposes, the assumption is that everyone's going to get the same mark because it's a group submission. If there's any variance to that, then individual marks will be adjusted accordingly. So table of contents, I've set up all the headings and everything. So please don't mess around with the headings. Please don't change the headings. Just include your part of the text where indicated. So if you need to update, I've given you some instructions here on how to update the table of contents. So just where it says place your text here, that's all you really need to do. Just place your text there. Don't mess around with any of the headings. Don't mess around with the table of contents. I want your submission to look exactly like this with your bits added. And if it doesn't, well then marks will be deducted because that's part of one of the submission criteria. So I've given you the headings here for each of the component parts. Again, where there's a diagram, you can include the diagram. Wherever there's text, please write your text. References are not included in the word count, but please, if you need references, include them there. And that's pretty much it. So that's the template. That's what it looks like. Use that as a basis for starting your assignment. Any questions you have, post them on the forum. Does anyone have any questions at this point in time? Yes?
So the declaration, you need to submit it at the same time?
It's part of that template document.
Okay.
So it's within the document. It's the first or second page of the document, so you just need to fill it out. And
It's like a cover sheet.
Well, it looks like a cover sheet, yeah, but yeah, it's pretty much part of the actual template. I've included it in the one document.
So Do you submit one each? Or
No.
do you submit,
One person submits per group.
yeah, but what about the feedback thing?
The feedback everyone will get. The same feedback. I've set it up in the system.
Oh no, I'm talking about the marking thing you had for that cover sheet thing the girl was just talking about. You know where you write down who did what?
Yeah, the declaration of conscience. So you've all got to edit that document, the one document, and say, I did this many words and I did this section, and then someone else goes to edit that document.
Oh, so you don't all submit that yourself?
No, it's all the one, yeah.
Oh, okay.
Okay, so you can email the person that is putting the document together, for example, and say, I did this many words and I did these sections, and they can write it in on your behalf or whatever. It's up to the entire group to ensure that what is written in that declaration of contribution is true and correct. But it's the one document that you need to submit on behalf of the whole group. Okay? If there's any discrepancies after the fact, which I've had that happen in some instances, feel free to email me or your tutor to discuss any concerns that you have in relation to how that submission has happened or not happened. Okay? Now, in terms of doing the work, you could, I mean, there's 4 parts to it. You could say you do part 1, I do 2, part 3, part 4. A strategy that I also think is a good way is you perhaps all go away and look at the assignment and probably just make some dot points on each of the things, or maybe, you know, 2 people pick 2 sections and other people pick 2 sections. Then you make some feedback and ideas about what you think should be going on in those sections. Come back and share your ideas. Then maybe go away and get one person to do one section and another, rather than just leaving one person to do the whole thing on their own, which they're not sure of. At least get 2 or 3 of you to share your ideas first in the first instance. Then you can perhaps go away and add further information. Because the more ideas you can get, the better it's going to be and the easier it's going to be for you to come up with the solutions to the questions. Or you could just have a brainstorming session and say, okay, let's meet today, let's knock out part 1. Let's meet next week, let's knock out part 2 as a group, and then someone can be the designated typer-upper or whatever you want to call it. Different strategies, it's entirely up to you. Okay? One thing I will mention though, for your benefit, is that remember you've got an exam to do. I will put a sample exam up. I will go through, you know, what the types of questions, but I'm telling you now that part C is going to be applying your knowledge. Okay? And part C is going to be very reliant on being able to draw the many diagrams and the things that we've done in relation to what we're doing throughout the course. So if you allocate yourself, for example, part A, and you haven't had practice in doing part C, you know, or part 2, 3 and 4, it's likely that there might be an exam question on those parts. And if you haven't had the experience of having to think through a scenario and put pen to paper and draw some of these diagrams, you might find it difficult when it comes to studying for the exam and or doing those questions in the assignment. Because you generally find if you've done it in an assignment, it's forcing you to think about the process of answering that type of question. Come to the exam, hopefully there's some recall of what you've had to do. So if you just focus on one part in this assignment, yes, you'll be really strong at that part, but you might not be as strong in the other parts. So that's my suggestion. So familiarise yourself as much as you can with every component of the assignment to help you with knowing everything that we've covered in the course. Okay? That's my tips. Any other questions? As I said, if you've got any others, feel free to post them on the course website in the discussion forum. Use whatever technologies you like to discuss the concepts and the assignment with your groups. So today we're going to, I guess, continue on what we did before the break in terms of looking at domain modelling part 2. Just a refresher on what we looked at. It is chapter 4 again, the second part of chapter 4. Last time I introduced the concepts of classes, domain classes, domain model class diagrams. Again, you've done some of this stuff and are probably doing some of this stuff in your database fundamentals course, for those of you that are doing it. I'm not assuming that you're doing it, but some of you should be familiar with it. Looking at naming of attributes, looking at naming of classes, different ways we name them depending on whether it's a class or an attribute. The class name, if it's 2 names, both should be capitalised. If it's an attribute name, the first one is lowercase and the second one is capitalised. Looking at domain model class diagrams, we can see that the association has a label on it. In today's tutorial we talked about whether there's an arrow that should go on the association name. I know that in your database course that you are being shown the arrow, and some tools actually show the arrow when you are representing them in your class diagrams. I'm happy for you to show an arrow if need to show which direction you should be reading that association. One thing I will mention is that in the textbook, not all associations are labelled in the domain model class diagrams. When we are doing these types of diagrams, whether it's in your exam, whether it's in your assignment, I want you to label the associations. Okay, so get into the habit of showing the classes, the class names, the attribute names, the multiplicity, and the association that occurs between those two classes. Okay? And again, we have the multiplicity here, and different things or different meanings that these multiplicities have, which again you'll get to practice in your tutorials this week if you haven't had your tutorial already. So here's a domain model class diagram for the bank, which again we looked at in the previous week, showing a customer having one or more accounts, account belonging to one and only customer. We've got some attributes here, we've got some primary keys shown here, and we've got some classes, multiple classes, and different multiplicity amongst those classes. So what's missing in this diagram?
Labels.
The labels, okay? So get into the habit of putting the labels here for your associations. And again, if you feel the need, if you think it's better and it's easier for clarity and readability, you can include the arrow to show which way that association label is reading. Again, we've got a course with university enrolment where we have a course with course sections and a student, and you'll see that we have, I believe this example we're looking at also as part of the tutorial, where we have students enrolled in 0 or more course section, and a course section can have 0 or more students, again with attributes. Another thing we think about here, which we talked about, or we didn't really talk about, but it's given in one of the solutions to the assignment, which you may not be aware of, and I talked about it with one of the students today, is we have something called an association class. So where we have a many-to-many association between two classes, we have a course section and a student, we have a many and a many, so we have the many-to-many relationship. When we have additional information that we need to store in relation to those two classes, we need to put that attribute somewhere, okay? We cannot put the attribute in student because we've got a many-to-many, so we're going to have duplication of grades and duplication of rows. We can't put the grade and associate it with a course section because that course section belongs, has many students in many course sections. So because we need to store something additional, what we do is create something called an association class, because it has attributes that need to be remembered, but those attributes cannot belong to either one of those classes. Okay, so hence we have a class with the dotted line representing the fact that it's an association class. An association that's treated as a class in a many-to-many association because it has attributes that need to be remembered. So if we have a many-to-many, need extra attributes to store them, we create something called an association class. Other things to consider about classes, more complex things to be considering. Again, you may or may have not covered these already. We have things called generalisation and specialisation, superclass, subclass, and inheritance. What we have here is we sometimes have classes that have attributes that are related to a whole bunch of other subclasses. We can have subcategories to talk about classes. We can also have subcategories within subcategories. Okay, so we can have a motor vehicle and we can have categories for a motor vehicle. In this case, we have a truck, a car, and a tractor. For a car, we also have types of categories of car. We have a sports car, sedan, and sport utility. Why do we create subclasses? And why do we create superclasses? And why do we have these things called generalisation and specialisation, and why do we have inheritance? Well, sometimes for a motor vehicle, or a truck or a car or a tractor, we need to have specific attributes related to those subclasses that are only relevant to those subclasses. But having looked at that, we can also have some general attributes that relate to all of those subclasses. So we create something called the superclass-subclass hierarchy, where the common attributes for all of these things appear in the motor vehicle class. The more specific attributes for a truck or a car or tractor appear in these classes. Similarly, we would assume through this particular representation that a sports car, a sedan and a sport utility all have specific attributes in relation to those particular subclasses. So not only does sports car have its own attributes, it also inherits the attributes that belong to the car class. The car class not only has its own attributes, but it inherits the attributes of the motor vehicle superclass. Okay, so it's a hierarchy, it's an inheritance thing. We have the superclass up the top, and we can split it up into subclasses. So that's how the generalization, specialization works for domain classes. Now, we can also have something called an abstract class. It basically allows subclasses to inherit the characteristics. So again, we can have a superclass, a generic class called an abstract class that has all the generic attributes. For example, for sale, we have sale date, time, tax, etc. So all the common attributes are put up here. And then we have 3 subclasses called in-store sale, online sale, and telephone sale. Now, we never actually get an instantiation or a version or a listing or whatever, however you want to call it, of an item called sale. Okay? When it's an abstract class, it never gets instantiated, because putting an abstract class in italics means it's an abstract class. We always have 3 types of sale in this instance: an in-store sale, or an online sale, or a telephone sale. They are the only 3 types of sale that can occur in this scenario. However, to avoid, I guess, duplicating these 6 attributes across these 3 types of sale, we pull them out and put them in a common abstract class up the top. Okay, so you can have the super... Yes, Dion?
What are the primary keys for the subclasses? Do they need one?
They do, and again, that's another convention that sometimes you do see and sometimes you don't see. Sometimes it's missing, and in this case it's missing. The primary key would be, it doesn't even show it on here.
The primary key would be the same as an abstract class.
But there's no primary key even shown here.
So would it take the primary key from the
Abstract class, usually.
Who said that?
Yeah.
Yes, yeah, okay. Yes, it would from the abstract class, because it's not, you're never going to have 3 different ones. You're only going to ever have one or the other, but it doesn't represent the primary key here for some reason. And it should. Or it could actually be probably sale date and time, because you would assume that that's going to be, it's not going to happen. You're not going to have 2 sales.
I reckon that's a bad assumption. Yeah, when you've got more than...
Yeah, concurrency and you've got multiple people. So,
Amazon.
sorry?
Amazon has like 15 a second or something.
Yeah, I know. I retract that comment. It's probably best to create another ID entry or item, which is automatically generated. And we can automatically generate these days with databases, just a specific unique key. So it's probably wise to create another field here that's called sale ID or something. So it's just a number that automatically increments.
the subclass will take that ID?
Yes. Yep.
Would that be a foreign key for the subclasses, or would it just be...
Yeah, the subclasses make a foreign key, but it's still their primary key.
Yeah. You're doing this. You're obviously doing this in another course, so.
I'm just trying to do my dough.
Okay. Maybe you two could have a little session in the break.
Like says, don't foreign key for them.
All right, this one's got. This is not an abstract class. and it's got keys here. Oh, actually, you can see it here, Dion, if you have a look here. There's a superclass here with subclasses, okay? And there's account ID is the key here. So the account ID key here acts as the primary key for either one of these. Okay, so whether it's abstract or not, the key sits with the superclass. Okay? Okay, so other ways we can represent, apart from the inheritance, superclasses and subclasses, and abstract class versus concrete class, we can have whole to part relationships, and we can have aggregation. Okay, and this basically allows you to show classes that either have components that make up the whole, and the whole doesn't exist without its components, or you can have a whole part relationship where the component parts exist separately and can be removed. Okay, so I'll show you have some examples here. We have whole part relationships with aggregation or composition. Depending on whether it's an aggregation or a composition will determine whether it's a UML diamond symbol or whether it's a filled-in diamond symbol. Okay, an example here of composition is an order item on an order. Without the order, there are no order items. A chip has circuits. Without the chip, there are no circuits. That gives you an example there of composition, where the parts cannot be removed because this thing is composed of these parts. Aggregation example, computer has disk storage devices, but the storage devices exist as devices apart from the computer. A car has wheels. Wheels can be removed and they are still wheels. Okay, so there's aggregation and there's composition. And here's an example here. We've got the computer, which has a processor, monitor, storage, main memory, and input device, and they are all parts of a computer. But they still exist as their own things, if that makes sense, in their own right. So, thinking about relationships versus associations, there are three types of relationships in class diagrams. We've got the association relationship, where we've got car has wheels, so the has is the association between the two. We've got the whole part relationships, where we've got the whole and we've got the parts that make up the whole. We've got the generalization and specialization relationships, where we've got the superclasses and the subclasses and the inheritance going on. So we've just got the straight two classes with an association in between, or you can have your whole to part, or you can have your generalization and specialization. So they're the three types of relationships that can occur in class diagrams. Different ways of representing different aspects of classes, basically, in your domain model class diagram. And it's really important to think about that, because if you've got just a straight multiplicity, two classes with an association, that's fine. That's what we've been practicing so far in its simplest form. But sometimes you can need to introduce, or sometimes you do need to introduce another layer, perhaps another layer of complexity or another layer to simplify the scenario, to demonstrate that, yeah, we do have some common attributes for a few things. Let's create a superclass, subclass relationship and show what the superclass is with the common attributes. Show the subclasses to identify that we have, three types of sales or different types of cars. Okay? Or let's break it down into a whole part relationship so we can show that the computer is made up of these particular parts, or a car is made up of these components. Okay? So different ways you can represent information in a diagram. So in terms of the RMO CSMS project, you can see in this example it has 27 domain classes overall. You can create one domain model class diagram for each subsystem, or you can create one for the whole system. What we've got here, so you can either split them up or you can create a whole version, depending on who your audience is and what, I guess, level of detail you want to show will determine which approach you take. it's probably good to use this as a guide to development. So we can see here we've actually got the sales subsystem for this example, domain model class diagram. We've got quite a few things happening here in this diagram. We can see that we've got an abstract class happening here called promo offering, which is information, association, I knew it started with an A. Association class, thank you for correcting me. Association class here. This one is the abstract class because it's in italics. So's online cart is an abstract class. So we've got sale is also a superclass because it has a number of subclasses. And the others are just your straight association type classes, relationships. What's missing in this diagram? Labels, arrows, okay? So again, get into the habit of including the association labels between these classes. There is sorry? Yeah, it's quite a busy diagram. Wait till we keep moving on, it gets busier. So this is the subsystem for sales, okay? This is the customer account subsystem. Okay, again, we've got an association class and quite a number of attributes. Here we've got a to and a from, so they've decided to label a couple of them, but not all of them. Here we've got the complete domain model class diagram, so it's basically a concatenation of a few diagrams, and you can see there's quite a lot going on. Okay, which is why it's probably a good strategy to create separate diagrams in the first instance to model your subsystems, if that's the case. If you're looking at only the one system, then fair enough, you only create the one domain model class diagram. But you can see here the different types of representations that we've talked about. Your abstract versus your concrete classes, your generalization versus your specialization, your association classes, your multiplicities. Okay, so understanding the relationships and how these classes all fit together and how they work together. And more importantly, thinking about what attributes need to be stored for each of these classes as well. So I'm going to assume that you've watched the video. If you haven't, please watch the video. It just gives you a little bit more information about what I've talked about today. How to read the diagrams, thinking about the different types of classes, thinking about the different types of associations that are represented in those particular classes. And I just want to finish off, I guess, we've still got a bit more to do, thinking about state machine diagrams. So each class has objects that may have status conditions or states, okay? And in order to represent those different states or state conditions, we can create something called a state machine diagram. And we need to be able to show the behaviour of the object when it moves from one state to another. So we have something called a state, which is a condition during an object's life. We have a transition, which is the movement of an object from one state to another. Put a few things together and it forms a state machine diagram. Now from a state machine diagram, we need to have an origin state. So we need a starting point. That starting point is called the origin state. We need to finish off somehow as well. In a state machine diagram, that's referred to as a destination state. So that's the state to which the object moves after completing a transition. Pseudo-state is the starting point. Action expression is the activity that must be done as part of the transition, and we'll see that in an example diagram. And a guard condition is where we can have a scenario where we represent a true-false test to see whether a transition can actually fire or be carried out. So here's an example of a state machine for a printer. Just a pretty simple example. The two states that the printer can have is off or on. Okay, off, on. The beginning pseudo-state is here, denotes the start of the state of the machine, behaviour of the object, pseudo-state. This is the first state that we can have for the printer. Off. Note that it says name as a condition or a verb phrase. Okay? Off. What we then have here is we need to have some sort of transition name to explain what happens or what triggers the printer going from the off state to the on state. And in this case, as it says, we can have a trigger, we can have a guard, and we can have an action expression. What we have here is the trigger being the on button is pushed. The guard is the true-false test condition. If the safety guard is closed, then we can run startup. And then the printer goes into the on state. How do we get the printer to the off state? We simply push the off button. So notice in here, the transition name, we don't always have to have a trigger, a guard, and an action expression. It can be a combination of those things. So here, we just basically have the trigger, which is the off button is pushed. All right, so we've got two states. We've got the transitions, and the transitions can vary in terms of how they are represented and what information you put on there, depending on what occurs from one state to the next state. So you can see here the syntax of the transition statement is a transition name with parameters. Again, sometimes we have the guard condition in square brackets followed by the action expression. Again, we talked about this with activity diagrams. We can have concurrency to show that we can have multiple paths in a state transition diagram. And the way we show that is through having the line with the arrows coming off there. Very similar to what we looked at with the activity diagram. So in this case, we've got a printer with concurrent paths. So if the on button is pushed with the safety cover closed, we run startup. Okay? We can either be on or we can be idle. Okay? If we are idle, we can either then go from idle back here after it's on to say that it's on, or we can go from idle and we can be printing something if something's asked to be printed. Oh, I don't want to extend. So concurrency basically shows, is used with synchronization bars, as we had with the activity diagram. And basically we have multiple exit points in an OR condition, or we can have synchronization bars to show an AND condition. Steps to creating a state machine diagram. I'm not going to go through them, but I've provided them here because you will have to do one in your assignment. Pick an object and represent the states of that object and show how it moves from one state to another. But again, really good sequence of steps of how to begin your thinking. And a lot of the things with these diagrams is to be aware that if you are presented with a scenario, what is the thinking that you need to do to extract the information from that scenario in order to come up with a diagram. That's really the trick to knowing. First understand what the diagram is, then understand how to read a scenario and how to extract the relevant information in the appropriate sequence to then come up with what the diagram should look like. And these steps are really useful in allowing you to do that. So quite a number of steps, but if you follow those steps in sequence, it's going to be really helpful for coming up with a diagram. So again, these slides, the following slides just really run through those particular steps in how to create a state machine diagram for a sale item in the RMO system. So we choose the item, sale item, we look at the particular states that item can have, and these are the transitions that are causing the exit from one state to another. If it's open, the sale is complete, then it moves into another state. So we've got open, ready to ship is another state. So we build the fragments, and it's really good to build these diagrams